Okay, so this is number 23 where you're continuing to interpret what the numbers in the equation mean. For number 23, they give the equation negative 8x. I switched the numbers around just so you would get the slope and the y-intercept correct. It's negative 8x plus 123. The negative 8 is the slope, which can be written as negative 8 over 1. The top refers to the rise, which is all about the y's. So when you talk about this number, when you go to interpret it, you're going to want to use the unit on the y-axis, ounces. Over here I drew a y and an x-axis for you. And in the description of this problem, it says that the y values are in ounces and the x values are in minutes. So I drew a little y and xy axis like I did in 21 and 22 and labeled them with those units so that I would use the units when I describe them. So the 1 refers to the run, or in other words, the x values, that's your run, and I'll be using the units on the x-axis when I describe it. So what this slope says when you go to interpret it, because they want you to identify and interpret, you are losing, that's what that negative means, 8 ounces. I use the word ounces on the top because it refers to the y's, and that's the unit on the y-axis. Per, that's this fraction bar right here. 1 is the number on the bottom, and then the unit that you put after the 1. Since the 1 has to do with run, the run has to do with the x values, and the unit on the x-axis is minutes. So 8 ounces per minute. The y-intercept, on the other hand, is the 123. All y-intercepts can be written as a point with a 0 in the front and the actual y-intercept in the y position. Again, all I did is take the units off of this xy axis and place them with the proper number. So the 0, being that it's the x coordinate, should be using the units on the x-axis. The 123, being that it's the y value of the y-intercept, I should use the unit on the y-axis. So to turn this into a sentence as an interpretation, at 0 minutes, there are 123 ounces in the bucket. So at 0 minutes, the bucket hasn't really started leaking yet, and then it begins to leak at 8 ounces per minute. Okay, then we get to number 24, same type of problem, only it's multiple choice. So in the description of the problem, it says the y values are given in feet per second. That's the unit on the y-axis, and then it says the numbers on the x-axis are in seconds. They give you this equation, y is equal to 32x, but there's no number after that, so that's the same thing as having plus 0. That being the case, the 32 is the slope. It is a positive 32, so we can use the word increase rather than decrease like we did for this problem, which had a negative. So this is the slope, it's 32, and I was saying in all the previous problems that were like this to write it as a fraction. Remember, another way to think of slope is rise over run. Rise meaning the y values, run meaning the x values. So when you talk about this top number, since it's all about rise, you will use the unit on the y-axis. When you talk about the bottom number, which is considered the run, or in other words, the x's, you will use the unit on the x-axis. So when you describe this slope, you can say that it is increasing by 32 feet per second. I got this unit from the y-axis because this top number has to do with the y-axis, 32 feet per second per every 1 second, or per second. When it's just 1 on the bottom, you can just use the unit if you want to, or you could say per 1 second. So it's increasing 32 feet per second every 1 second. That's the meaning of the slope, and I believe that was choice B. And if you look at these choices right here, you had to rule out choice A because they tried to say that the slope was 0, but that was really the y-intercept. And in choice B, the speed of the ball increases at 30. You got to look at the units that they put right after the number. The 32, you're supposed to be using the units on the y-axis, feet per second, and they did. And then for when they talk about the seconds, every 1 second. that's referring to this number on the bottom. So everything is correct up until that part, and I'm going to read on. I'm right here. Y-intercept is 0, and on a graph that is right here. Y-intercept that's 0 means that there's a point on the y-axis at 0, which can be written like this. So when you interpret that, you're going to say let's see how they explain it, the speed of the ball in feet per second was 0 at the moment that it was dropped. So when it first began the drop, it was at 0 feet per second. 0 feet per second. So that was choice B. That had everything we needed in that answer. Problem 25, I believe this is the last description problem. There might be one more on the next page. Okay, so 25. So 25, the amount of water in a leaky bucket is given by, let's see, y is equal to 113 minus 4x. Okay, so again, this is written backwards. You could rewrite it if you want to, just so you don't mess up. And I don't know that you need to do this, but here's your slope. It's the number in front of the x, and then it's a positive 113. So the slope is negative 4 over 1. If you want to put units on here, then you have to know that this is about the y's, the rise, and this is about the x's. So as you read this problem, it says the y is in ounces, x is in minute. The y's are in ounces, the x's are in minutes. So you want to interpret this, you could say that it is losing 4 ounces of water. I'm talking about the leaky bucket, losing 4 ounces of water per 1 second, or per 1 minute. The units are minutes, per minute. You could say per 1 minute or just per minute. Okay, that's an interpretation of the slope. Then the other thing is the y-intercept. This is the y-intercept back here, which can be written like this. And then again, it's all about the units. This is the x value, so you're going to want to use the units on the x-axis, which were minutes when you talk about it and interpret it. And on the 113, which is the y value, you're going to want to use the units along the y-axis, which is ounces. So at 0 minutes, the bucket contained 113 ounces. Okay, and those are interpretation problems. There's a lot. I just did a lot of examples of that. Numbers 21 all the way through 25 are interpretation problems. Let's go on to the next type of problem. If there's any more of these, I think I'm going to go on because that's quite enough of that. Let's see, representative, what does the ordered pair mean in the context of this situation is another interpretation problem. Let's go to 27. And let's see if this is something different. 26 and 27 are also interpretation problems. I've already done 5 of those. So I'm going to go to go to 26. All right, let me see if there's something else to do here. Suppose that during a certain step, we'll do 27. Okay, so 27, we could kick in with that. In number 27, they give you a function. This is called, it's just something to plug into. You have the function over here. This is just the name of the function. The name of the function actually can be replaced with y. when you're plugging into these. So no, regardless of what this is called, it would be called h of t. The variable that you see here will be the variable that's over here in the rule, in the function rule. And you're going to plug in. But you can replace this whole entire function notation with y. And then you can plug in over here. So this plays the role of the x, this plays the role of the y. So now what they're saying is t is the number of seconds since the rocket started. Find the distance when time is 3 seconds. So you're going to put a 3 in there, and then what they're trying to see here is if you understand order of operations. Please excuse my dear Aunt Sally that says do parentheses first. If there's anything to do inside the parenthesis, there isn't. You just have a plain number. There's not actually an operation. Okay, so that's done. Then do exponents. So I've got to do this first. Times 7, because when they're right up against each other, that means plus. Now you have a choice between doing this or this. Both multiplication and division always come before any kind of addition or subtraction. So don't go adding those first. This happens first. So 7 times 9 is 63. Then you're going to add 18, which is 81. Okay, and so it says we're to find the distance when time is 3 seconds. Okay, so that would be choice C. Okay, then let's go to 28. Let's see what we have there. Okay, so for 28, again, they give you another function. Here it is right here. Again, the function name can just be called y if you'd like. You can always plot it as a point. This is the actual rule that you're using, g squared minus 0.08. You're going to need to use your calculator here because of all these decimals. Okay, so now the question is, use the function to find the weight of the mouse when the mouse is fed 12 grams of food. And the G stands for grams of food. So you're going to go 0.66. They have asked you to plug in 12. And it's 0.08 times 12 plus 8.7. You're going to use your calculator to get this answer because of all the decimals involved. But you just need to know what to put in your calculator first. So the very first thing you're going to put in your calculator is this exponent. You're going to go 12 squared, get 144. So it's going to be 0.66 times 144 minus 0.08 times 12 plus 8.7. And that you can put directly into your calculator as well. Just 0.66 times 144 minus 0.08 times 12 plus 8.7. And I got 102.78. Let's see what choice that is. Okay, that would be choice A. Okay, moving on to number 29. The cost Y dollars of a car rental is the number of miles driven, X, and is approximated by this equation. Estimate to the nearest whole dollar the cost of the car rental if the number of miles, and again, see number of miles driven is X, just to make sure you're putting the numbers that they're giving you in the right place. So 23 is something you're going to put in for X. Okay, so here's the work for this problem. It's going to be Y is equal to 0.25 times the X value, which they're telling you to plug in 23 plus 10. And then you just go ahead and put that in your calculator. exactly like you see it here. 0.25 times 23 plus 10. And you get 15.75. And then you're going to round it to the nearest dollar value. So $15.75 is closest to this answer. So choice A. 30. A bus company begins a business with 71 buses. There it is right there. Each year they increase the size of their fleet by 4 buses. Complete the following table and write a linear equation to model the fleet size after X years. Okay, so if you're increasing it by 4 each year, add 4 here, you'd have 79. Add 4 here, you'd have 83. Add 4 here, you'd have 87. Add 4 here, you'd have 91. Let's check those. Add 4, add 4, add 4, add 4. And then you want to write a linear equation. So you want to use, this is the formula. You're going to, again, make sure you have these formulas on your formula card. The slope is rise over run, which you can get like this. It's the difference in the y's. So you can just take one y minus the other one. Let's see, you can go this minus this and then this minus this if you'd like. I'll do the work right here. So 71 minus 75 and 0 minus 1. So that would be negative 4 over negative 1 or just 4. You could also just do it like this. See how there's a 4? It's an increase of 4 each time. That's your slope. And you know that it's going to come out positive 4 because it says each year they increase by 4. So this difference, it's 4, it's this difference over this difference, but the difference here is always 1, so it's going to be this over this, and you know it's positive if you don't want to actually do this for it. So you come over here, the slope that we just found is the 4. It's that constant increase that you see happening from year to year. Copy the x, and then this is what we call the y-intercept. Any point where the x is 0 and then has a y value, that number is the y-intercept. So that goes there, and that is your equation. Moving to number 31 and using the same formula. Y is equal to slope times x plus b. This is the slope-intercept formula. Okay, so here they just flat out give it to you. Here's the slope, plop it right in there. And then the y-intercept is the number in the back, not the 0. Okay, if you don't want to have a double sign in between your 2/3 x and your 2, anytime you have a plus followed by a negative or a negative followed by a plus, that combination of a plus with a negative, regardless of which one comes first, is a negative. Okay, so this is the answer for number 30. This is the answer for 31. Okay, moving to the next problem. Okay, so let's see, and we continue with these same types of problems, doing the equation of the line. So it's y is equal to mx plus b. I'll just write the formula down so you can keep seeing it and memorize it. So slope is 2 plus the y-intercept, which is negative 2/7. Again, you can get rid of this double signage and just write it as 2x minus 2/7. Same thing here. Using this same formula, really simple. Just put the slope in front of the x. X off to the side like that when it's a fraction. And the y-intercept is 0, which you can give me this answer as well. When this back number is 0, then you can just write y is equal to just 1/3 x. So this is the answer for number 32. This is the answer for 33. Okay, solving a system. Now for these, they start you off with some pretty easy problems in numbers 34, 35, and 36. They're simply suggesting that this point is an answer and asking whether you agree or not. So the work for that would involve you just plugging in the suggested point and seeing whether it works. It has to work in both equations though. So if you're going to check positive 2, negative 3 for number 34, you're going to be plugging it into both equations. So one of the equations is x plus y. You got to leave blank spots for the variables so you can plug in the numbers. Okay, for the x, put the x coordinate. For the y, put the y coordinate. Now the minute that there was a negative 1 here, so the minute that you add these two, you get a negative 1, and there was a negative 1 on this side. So far it works out, but it has to work for both. So now put it in the bottom equation, which goes x minus y is equal to 5. Now if these numbers work to give you a 5, then this 2, negative 3 is a point that satisfies the actual entire system. Okay, double negative is the same thing as positive. So on this side you only have 2 plus 3, and yes, you have a 5 on both sides. So the answer to this one is yes, choice A.